This conference will now be recorded.
Hello students, one more time. This is chemistry and unit 4, first topic. The name of the unit is atoms, elements and molecules, and the first topic is our material world. Here we have some scientific terms: mixture, and their properties, physical change. As you see here, evaporation, metals, chemical reactions, alkali, and so on. Especially physical change and chemical change are the main consideration in this unit. Okay, also we talk about the mixture, the second in the second unit of the chemistry, and also the separation methods of the mixture. And we talk that if the mixtures, elements, compounds, chemicals, they just mix together, no any chemical bond, no any chemical relationship between them, just they mix together, and also we can use some physical separation methods to get them out, like filtration. Also we did these experiments in our laboratory, evaporation, crystallization, then paper chromatography, simple distillation, and so on. Okay, here written that sometimes over time we have learned to use these materials to make objects to improve our lives. Yes, it's correct. Science is always improving, developing, so all of them for improving our lives. But sometimes we misuse our material world, so it causes to decreasing or run out the Earth's how can I say materials, resources. Okay, so we have to know in which way we should use our resources. And physical change and chemical change. What is that? Here, the objective of the lesson is again to start differences between a physical and a chemical change. The first of all, let's learn what's matter. Again, actually, in the fifth grade too, this lesson learn matter. Matter is matter is everywhere, and it's anything that takes up space and has mass. Any particle, let's choose the smallest particle. For example, atom. The smallest particle is atom, but atom itself has mass and it occupies space. So it is taken into account as matter. Also, subatomic particles, very small particles, also they are considered as matter because of course, the mass is very small, but at least they have what mass and they takes up space. So, physical change. What happens in a physical change? In a physical change, guys, there is no any changing in the structure, in the composition. Physical change that alters the form of the substance. Alters means that changing the form of substance, but doesn't change in another substance. It changes shape or size. Dissolves. Dissolves means making the solutions, making the mixtures. For example, trying dissolving the sand in the water actually doesn't dissolve, but it's insoluble, but itself is mixture. It changes phase, freezes, boiling, evaporation, condensation. All these processes are physical processes. For example, you have ice. Ice. Water is in ice form below the 0 Celsius grade. When you apply heat, it turns to water. Still, the structure is H2O, water, but in ice form it is in the different state, in liquid form is different states of matter. If we keep applying enough heat to the liquid, the intermolecular attraction forces between the molecules, between the particles are broken down, so liquid turns gas to the steam, but still the steam is H2O. You see, the composition doesn't change. Composition doesn't change. but the phase changes. And of course, they have their own names, but we learned them before this topic. Example here also we have making orange juice. Physical change occur when matter changes property but doesn't its chemical nature. Yeah. And again, here we have some information. Physical property change could include a change in texture, shape, size, color, odor, volume, mass, weight, and density. Let's say you have metal and you molded the metal into different shape. It's called, for example, in the chemistry, malleable. And malleable ability of metals means that you can give them different shape, you can hammer them into different shape. Let's say you have aluminium. You can use aluminium to make the frame of, let's say, windows, but still it is aluminium. The chemical nature, the chemical identity doesn't change, but the form of the material changes. So this is physical change. Okay, and let's say color. You have a table. You bought any color, the dye. You're starting to paint this table, and you change the color of this table. But this is physical process because you're just changing the color and shape or size. Let's say you have wood, but you cut the wood, let's say with a knife or with another tool. Again, this is physical change. Why? Because you just change the size with the physical processes, not with the chemical reaction. Okay. Then here, guys, you have again we have some examples here of physical change. Um, Cutting paper is physical change. Ice melting. Look, ice melting. Ice. It is 0 C and below the 0 C it is ice. But 0 and above 0, between 0 and 100 C, it starts to melt and turns liquid water. So this is physical process. Then we have, look, something wood. This is physical change. Disappearing puddle. This is physical change. Why? Evaporation happens here. And also we talked differences between boiling and evaporation. Boiling, for each compound, for each liquid, let's say, it has own boiling point, specific boiling point. For water, because it's a famous one, 100 centigrade, but evaporation can happen at any centigrade. Evaporation because just happens on the surface of the liquid. So this is physical process because no identity change there. Just the molecule start to escape. Dry ice. Dry ice is carbon dioxide, and the sublimation process happen here. You know, guys, sublimation happen just in. Okay, let's open here. Paint. Sublimation process happens. Sublimation process happens. This is turns solid to directly gas without getting liquid, liquid. So this process happens just in dry ice, which is carbon dioxide, and also iodine. In normal conditions, sublimation happens in that chemicals. Okay, without getting liquid, salt turns directly to the gas. Again, this is physical change. The next we have chemical change. But what happens actually in the chemical change? In the chemical change, students, the chemical identity, structure change. Yes, you will get new compounds. So far, we learned some chemical reactions. You know, we have mainly two ways to show the chemical reactions by chemical words and symbolic equations. Word equations and symbolic equations. But of course, right now in the 5th grade, we don't know the chemical symbols of the elements in a periodic table. So we mainly prefer writing the chemical reactions with words, and respiration reaction, photosynthesis reaction, and neutralization reactions are very important in the science. In achievement tests, always you will see these reactions and you have to know them by heart. have to learn them. Okay, and look, for example, in neutralization reactions, the writing acid plus uh, alkaline or base will get what? Salt plus water. This is neutralization reaction which happens between acid and alkaline. Acid and alkaline, they combine together, or they are not combined, sorry, it is kind of a double displacement reactions. Anyway, guys, there are two parts in the chemical reaction: left hand side and right hand side. Before the arrow, left hand side; after the arrow, this is right hand side. This part's called reactants, this part is called products. Reactants, also another name is raw materials. Raw materials or reactants, atoms, the particles rearranged to make new compounds, new chemicals. So this is chemical reaction. In a chemical reaction, in a chemical change, we will get new kind of chemicals. Okay, it can be decomposition reaction, combination reaction, single displacement, double displacement. Anyway, we will get new chemicals. Before the arrow, on the left-hand side, the atoms rearranged to make new chemicals. Okay, this is chemical change. In the chemical change, we can talk about new chemicals. So when something burns, let's say this is kind of sign of chemical change. Also, let's say when temperatures change without heating or cooling, again this is chemical change. If the bubbles when gas is released out, it is sign of chemical change. For example, guys, we have indicators to indicate is it alkaline, neutral, or acidic solution. So when we add let's say the phenolphthalein or litmus paper, blue litmus paper to the acid, turns red. So changing this color is chemical change, and forms a precipitate. Precipitate means that it's insoluble in the solution, in the water, in the solvent. That's why it is settled down as a precipitate, and it's also a sign of chemical change. And also you see here fizzing, light production, smoke, bubbling, baking cake. They all are examples for chemical change. Okay, and look, color change. And color change means that here, guys, the color, you don't change color yourself. Here the color change happens naturally. That's why it is a chemical change. And the precipitation, look, in the precipitation, it's in new compound which you get after reaction, insoluble in the medium. That's why it is settled down. And gas production, for example, alkaline metal react with water, we get hydrogen, and this fizzing, this hydrogen, gas production bubbles are the sign of chemical change. And temperature change in the firework, it is also chemical change, and like this. And look, chemical change, all are examples for chemical change. Look, here also we have another example. Toast burning, yes, this is chemical change, because in the burning process also it reacts with oxygen, and in the burning reactions it requires oxygen. Rocket fuel burning, it requires oxygen and it reacts with oxygen, and this is chemical change. Metal rusting, again, yes, it is in the rusting process. For example, iron, it reacts with oxygen and water, and other corrosion process of the metals that react with oxygen and new chemicals, new, let's say, oxide, which is new chemical compound, new substance, takes new substance are getting from this reaction, and that's why it's considered as chemical change. Candle burning, yes, of course, is chemical change because it reacts with oxygen. And identity the change. Tears here, okay, here we have some examples. Tears of paper, is that physical change or chemical change? The first of all, guys, try to um, identify the answer by yourself. Try to figure out the differences between chemical change and physical change by yourself. Here's a paper. Is it chemical? No, guys, physical change because you changed the paper, the size of paper. Mix salt and water. This is making mixture, and making mixture process, also separating the mixtures, are physical change. Burns paper. Burning process means it reacts with oxygen. This is chemical change. Evaporates salt water. This is separating out of component of the mixtures. This physical change. Mixes vinegar and baking soda. Again, it is neutralization reaction, and that's why it is chemical change. Then writing activity, guys, is homework for you. You can write a paragraph about the difference between a chemical and a physical change. There are a lot of massive examples in the internet. In the Google, you can type the name of the topics there, and also you can search for new examples, for new conditions, for new, let's say, processes, which you can give examples for the chemical change and the physical change, and you can write a short paragraph about it, and you can please bring this paragraph to the lesson when schools open. Then, okay, guys, thank you. The first lesson finished. See you next time. I mean, see you, of course, I can't see you here, but anyway, thank you. Bye.